this is the first lesson in Unit 5. Unit 5 involves some lessons to do with collecting data and interpreting data, which is going to be obviously an important thing when we are dealing with statistics. And it also then goes on to look at one variable analysis of data. So the first couple lessons are going to involve a lot of terms and concepts, not much in the way of math calculations. And then lessons 5.3 onward are going to be more calculations again to do with one variable analysis. So our first day of concepts and lessons is 5.1, data concepts and collection. So data exists in many forms, but there are two main types, numerical and categorical data. So this is the first of several distinctions I'm going to make. So again, I'm going to just sort of throw out some terminology that we need to get used to so that we can then talk about data intelligently. So the first one is breaking down data. Well, in fact, let's talk about data for just a second before I get into breaking it down further. Data is our raw information that we work with, right? Up till now, we've been talking about probability, and probability is very closely related to statistics, but it's not exactly the same thing. Statistics is information that's actually gathered from somewhere. It's based on information that's gathered somewhere. So it might be from a population of people or plants or processes that go on in the actual world. And rather than doing experiments, what we do is we do studies. So we look at what's already out there. So I might, to take a simple example, want to collect data on the heights of everybody at Uxbridge Secondary School. And this is not a probability thing anymore. I could actually get the height of everybody in the school, and then I could analyze it to figure out what the average height is and what the average range is and various other things like that. That's what statistics is. All right, definitely it's connected to probability, because if I have that statistical data and then a new student comes to Uxbridge that I don't have any information about, if I know what the average height of a student in Uxbridge is, then I could take a guess at what the height of the new student that I know nothing about is. So there's a connection there. All right. So if we're going to talk about data, we need to dig a little bit into that. So the first thing, like I said, we could break things down into numerical or categorical data. So numerical data simply means data that has a number attached to it, like height. Height would be a numerical piece of data. Categorical would be something that doesn't really have a height attached or a number attached to it. For example, eye color. That's one I go back to as a regular example. So either something is numerical or it's categorical. It can't be both. So when we're analyzing data, we want to think about which of these categories or which of these types of data it falls into. We can then break them down a little bit further. Numerical data, which can also be known as quantitative, you're going to hear that term sometimes, can be broken down farther as discrete or continuous. Discrete means that you can count it. So we don't break it down into decimals or fractions, and continuous can be broken down. So often I'll describe discrete data as something that's countable. So people, cars, trees, books, those are all things that I can count. Continuous data is something that we don't count so much as we measure it. And some examples of that would be things like volume, time, distance. It makes sense for all of these things to be broken down into fractions or decimals. So again, that's a further breakdown. So here's a little illustration of that. And so again, a different rewording of this. Discrete data can have certain values with gaps in between. The number of members of a family is an example of discrete data. People, right? We don't have half a person. A bar graph can be used to represent discrete data. So bar graph. We've all seen bar graphs in the past. Generally, a bar graph is something that is shown to be, it looks, well, it's got bars. It can be horizontal like this one is. It can be, usually it'll be vertical, but usually there's gaps in between the bars, as opposed to a histogram, which we've talked a little bit about up to now, where the bars are all together. So bar graph is what we can use for discrete data, although we could use a histogram for discrete data as well. Continuous can only have any value within a range. So the height of a tree or the height of anything is an example of continuous data. And then we definitely want to use something like a histogram to represent it. So again, a histogram looks like a bar graph, but the key feature of it is that it has all the bars together. Let's take a closer look at this. This is definitely a histogram. And as opposed to just having things like, if we look at this bar graph, we have the number of children in a family. So you could have 1 child, 2 child, 3 children, and this is horizontally set up, but that doesn't matter. You can't have anything in between, say, 2 and 3 children. You can't have 2.5 children. So we have these discrete bars. Heights of trees, though, we can have any height for a tree. So we have a bar, say, here, that's between, that runs between 100 and 150 centimeters. So what we're doing with a histogram is we're grouping things together. Any tree that has a height that's between 100 and 150 centimeters would fall into this interval. And then we could have another one for any tree that falls into this interval between 150 and 200. So we're grouping things again together. And we have to do that for continuous data because otherwise we're not going to have a lot of repetition. We'd have to have an infinite number of bars for every possible height or piece of data. So we group them together for continuous data. As far as categorical data goes, we can break that down a little bit as well. So categorical data can also be known as quantitative data. Sorry, quantitative was numerical. Qualitative data, as in like we're describing it by the qualities that it possesses. Data can be put into distinct groups, summarized as totals or percents. 2 main types are ordinal and nominal. And again, we'll explain what that is a little farther down. Ordinal data makes sense being ranked or shown in a specific order. So the example they show here, none, very little, same, a lot. So a lot of surveys out there ask people to rank things from none to a lot, or extremely disagree to extremely agree, or whatever. So we have this sort of continuum. So it sort of makes sense to have things in an order for some things. So ordinal means order, whereas nominal is unranked stuff, where order doesn't make sense really. So the example shown here, number of colors in a bag of M&Ms. This goes green, red, yellow, blue, orange, brown, but there's no reason behind that order. Green didn't have to come first, brown didn't have to come last. Green isn't any better or worse than any other color, though you might disagree. So there's no order, so that's what nominal is. If you can't put a logical order on things, then it's nominal. All right. Now I'm just going to get all the sort of definitions out there first, and then I'll get to the examples afterwards. So another thing that we want to look at then is some definitions like population, sample, and so on. So we need to go back to, again, think about what the purpose of data collection is. The reason is so that we can analyze things, we can learn things about the world. So if we're going to learn things about the world, we have to think a bit about where we're getting our information from. Are we getting it from the population, which means that we are actually looking at every single thing within the group, the entire group? Or are we looking at a sample, which is a subset of the population? Often a population is too large or too difficult to collect information from, so we'll take a sample. If I wanted to get an idea of what every person in the entire world thought about any topic, fill in the blank for pick a topic, it would be pretty tough for me to go and ask every single one of the billions of people on the planet Earth about that topic. So what I would do, or what I could do though, is take a sample. I could take a smaller group. I could ask certain people their idea, and if I design my goal, my study well, then this sample can represent the entire population. So the goal of selecting a sample is that it is representative of the population. So that is very important. Use a different color for that. It has to be representative. With multiple samples, we are able to eliminate variability in the samples so that our data is consistent. So if I take one sample, then, maybe if it's a good sample, then I might have an idea of what's going on for whatever I'm studying. But if I take multiple samples and I am able to repeat what's going on, or repeat my results, then I can be even more sure that I've got good information. For a sample to be representative of a population, each member of the population must have an equally likely chance of being selected in the sample. So, selection of a sample must be random. Again, that's really important. Random is how we get to it. Now, it doesn't have to be 100% random, but definitely randomness is got to play a role. If the sample is not random, then it is biased and not reliable. So I think this is our last overall term. So bias is when we get results that don't represent the way things really are in the world. Maybe I do a study on something. Maybe for example, let's go back to the heights of people at Uxbridge Secondary School. So I go in, I take a sample, and I think it's random, and I do my best to try to get a good group. But maybe I only take my sample from grade 12s. Well, if I only took my sample from grade 12s, they are by and large taller than people in grade 9 or grade 10. And so my results are going to be skewed. They're going to be thrown off. I'm going to think that the average height in Uxbridge Secondary School is actually higher than it really is. So that's a simple example of bias. So we want to avoid that. Here are some specific types of samples that we can take. As you can see, I've already filled in some of the characteristics so that you don't have to wait while I write them all out. You're welcome. But let's just quickly do a survey of them. So the easiest one, or the most basic one, is called a simple random sample. Characteristic of it is that all members are included. So imagine a big hat with everybody's name in it, and you just pull names out of a hat. Everybody has an equal chance of being chosen in a simple random sample. A systematic one, systematic sample. So it's still, every one of these should involve some level of randomness, but so we just get a bit more fancy with each one. Systematic, what we do is we arrange members into an organized pattern, then choose every nth member, and so there is, the randomness comes from the fact that we're not picking people specifically. What we're doing is we're just letting the, say we took every 10th member on a class list. The randomness comes from, you don't know whether you're going to be the 10th person or not. So it's still fairly random. The example here, all patients of a doctor in some way, or they're organized maybe in alphabetical order, choose one randomly, and then we take every 10th person on the list. Stratified gets a bit more fancy again. What we do is we take all the members of a population and we organize them into some sort of group with similar characteristics. A representative proportion of each group is randomly selected. So this proportion idea, that's the key here. So let's look at the example. A survey of factory employees about new safety initiatives is done, if there's 1,000 employees in the factory, of which 633 are women and 367 are men, so in other words, there's about twice as many women as men in this factory, we want to survey, we want to go out of our way to specifically survey more women. So maybe they take 10% of them, 63 women and 37 men. Now, they still have to choose those 63 women and 37 men randomly, but it's proportional. So the sample, the makeup of the sample is proportional to the makeup of the population. Cluster is another way where members are put into groups. Just like in stratified, things are in groups, but instead of taking a proportion of each group, we randomly select entire groups and then study each member of the group. So there's some similarity between stratified and cluster, but there's a big difference. So it's not proportional by group, it's entire groups. Example given, survey Little League Canada baseball players, randomly select 5 districts in each province and give the survey to every player in that district. So we don't take, say, one player from each district. We just get everybody in a particular district, in a particular group, then survey all of them. Multi-stage consists of 2 or more stages. So in this example, if it's at a business, they randomly select stores, and then within the stores they randomly select departments, and then in the departments they randomly select people. So that's the idea of the multi-stage. Those are all decent ways of collecting samples. The last 2 are not super good, but they have their place. Convenience. A convenient sample is literally one that's convenient to the person doing the survey. That makes it easy to get the data. The problem is the results are going to be biased. And the problem is that it's not really random, is it? Let's look at the example. To get public's input on a new pet bylaw, a local politician goes to the park and asks people their opinion. So that's convenient for them, but it's not random. It's only people in the park. And some people might not go to the park. Maybe they're sick and shut inside. Maybe they just don't like parks, but they still have pets. So it's going to be biased. It's not, everyone doesn't have an equal chance. Voluntary has the same thing going on. Again, it's going to be biased. It usually involves rewards of some kind, such as if someone phones you up and offers you a free vacation if you fill out a survey, that kind of thing. For example, conduct an online poll asking people whether banning junk food in schools will fight obesity. No reward in that one. It doesn't always have to have reward, but it's voluntary. So not everybody is going to respond to it. Only people who probably have some sort of interest in this. Some people might feel very strongly against having junk food in school. They might be the only ones who respond to this survey. Whereas people who don't care as much, they might not respond. And so again, we're going to get skewed results. All right, so a lot of information there. Let's just do really quick run through some examples so that we can try to put a little bit of this together. So example 1, for each graph, identify the type of data, give reasons for your choice. So the first one is survey asked students what was their travel time to school. All right, so travel time to school. So we're back to types of data, right? So is this numerical or is it categorical? Well, if travel time is definitely a number, so it's numerical. And then if it's numerical, is it discrete or is it continuous? Well, we've seen before that time is a continuous thing. We can break it down and it makes sense. And if we look at the graph, again, we can see it's a histogram that goes in intervals from 0 to 5 minutes, from 5 to 10 minutes, and so on. So that all matches up with continuous numerical data. Write one statement about what the data show. Well, pick one. We could say that the majority of students take between 10 and 15 minutes to get to school. A student records the hair color of people entering a high school dance. Okay, well, first question then is this numerical or categorical? no numbers involved. Now, there are numbers involved. If you look at the graph, we can clearly see that, that some 10 people have brown hair who come in and 5 people have blonde hair who come in. But that's not really what we mean by numerical. We mean the basic concept. Is that numerical or categorical? And red, blonde, brown, black, purple, green, these are definitely not numerical concepts. So this makes it categorical. And as far as categorical goes, we have ordinal or nominal. Doesn't make sense to put it in order. And I would say, no, it doesn't make sense to put it in order. Red is not better than blonde. There's no reason why red had to come first. No reason why green had to come last. It's a random ordering. So, again, what can we say? Well, we can say, if we want to make a comment about it, we can say, well, most students who came into the dance have brown hair. The number of candy bars students brought to the school after Halloween. So again, this one looks like a bar graph, just at a glance. When I look at the horizontal axis, the variable, it's number of candy bars, right? So I would say this is numerical. However, this time it's discrete. You can have 1 candy bar, or 2 candy bars, or 3 candy bars, etc. And what do I want to say about this one? Well, maybe I'll just say that for some reason, no students brought exactly 4 candy bars to the school after Halloween. And our last example, in each case, identify the type of sample. And so the first one, you want to find out if your town is in favor of starting a composting pickup service. You ask everyone on your street. To me, this is the key. Everyone on my street. That doesn't seem very random to me. In fact, it seems pretty convenient to me. Maybe there's something different about the people who live on my street compared to other streets. Probably we all make about the same amount of money because our houses are probably all worth about the same. So I'll get an idea, but it certainly won't be, there's certainly arguments against it. A university poll of its students selects 200 students at random in the same proportions as the enrollment in each department. So what they're doing is they're breaking it down by department and they're taking a proportion, maybe 10% or 5% or whatever. Whenever we're taking a proportion, then we're talking stratified. There are 139 swim clubs in Ontario. Swim Ontario conducts a survey to vote on its new logo. Organization randomly selects 10 swim clubs and surveys every member in each of those clubs. So what we're doing is we're putting things in groups and then randomly selecting some of the groups, but every member of the group. So that's definitely cluster. Coach puts the names of all basketball players into a hat, draws one name for a free basketball. That's simple random. A questionnaire is sent to every 9th person on an alphabetical list of a store's credit card customers. First person chosen on the list is picked randomly. As soon as we see that idea of every 9th person, every 10th person, every 3rd person, anything like that, that suggests systematic. And finally, student council invites students to provide ideas for activities. So it's just throwing out an open question, wants to get an idea of what people think. This would be voluntary. That's it for this lesson.